Good day, I am on Michael Nene, and today I am going to show you a demo on how to create a logic circuit IC using AND gate and the NAND gate. The video will be separated in two parts. This will be the first part that contains on how to create a logic circuit using the AND gate, and the next part of the video, which is the NAND gate. And to start things off, we would like to create a circuit, add circuit, and name it IC7408. IC7408, and there you go. And then we will be going to the IC7408 circuit and add some gates. Add gate here, and since we only have two inputs, the number of inputs will be changed to 2. And then we have this pin, which is called input pin, and we will take it to the side. Paste. We only have I mean we need to have two pins since the gates have only two pins in the input. And for the output, here is the output pin facing south, and then connecting the dots. We will connect the dots here and then and here. We can put the input by clicking it, the hand icon, and then click here. As you can see, if we inputted 1 on both inputs, that will be 1, which satisfies the truth table of the AND gate. In the AND gate, you will only have an input of 1 if you have, you will have an output of 1 if you have input of 1 on both inputs. And if it is not 1, otherwise it will be 0. Just like this. If I change it, it will be 0. And if I change this, it will be 0. Blinking this or this, nothing will change. And to prove what I am saying, we can analyze the circuit by highlighting this, and then analyze the circuit by right-clicking the IC7408 and analyze the circuit. And by analyzing the circuit, it will display the combinational analysis. This will be the combinational analysis, which contains the expression, the inputs, outputs, and the table. In this table, you can see that if the inputs are both 1, the output will also be 1, and otherwise it will be 0, as you can see here in the truth table. And proceeding to the circuit, there you go. We will be replicating it. We will place it here. And then we will put another here on the bottom side, and then changing number of inputs to 2, and then input boxes and the output circle. There you go. We will be rotating it facing right, and then connect dots, and there you have it. And then we will be replicating it again here. There you go. And we will be imitating the truth table. In the left side of the truth table is the X or A. So we will be, the sequence of the X or A will be like this: 1 1 0 0. And for the B or Y, which is the right side, and it will be like this: 1 0 1 0, since it will be alternate. The left side is the X or A, And then before we go to the next, we will be labeling these pins, because in a real IC, the IC has 14 pins. It comprises, the seventh pin will be the so this the seventh pin is the ground, and the 14th pin in the upper side is the VCC. We will be labeling it this as the first pin. Uh, there you go. The first pin, which is facing south. This one, south to south, 3 south, 4 oh no, 4 south, and then 5 south, 6 south, and as I have said a while ago, the 7th pin is the ground, and the IC can run here in the application without the ground and the VCC. So uh, we can disregard the VCC and the ground. So that explains why the 7th pin and the 14th pin is not present. And the 8th pin will be here. This will be the 8th pin, 8 north, 9th pin, 9th, 10, 11. Oh, oh no, I'm so sorry. What? 11. There you go. North. 12, and then north. 13, and the north. And that completes our pins here. And then we will be proceeding here in the main circuit. And we will be driving it here. There you have it. And then uh, to prove that our IC is working, we will have to conduct a sample test. That goes here. Oh, uh, these guys will be facing up north. I will be I will be adjusting this here, here, and then copy paste, and then we will connect the dots again. uh, there you go, there you go, and then this guy, and there you have it. They are connected. We will be inputting some in the input pin to get a one output. We have to enter 1 in the input, in the both inputs. There you have it, and otherwise it will be 0. If I put 1 here and then 0, 0. And if I put 1 here and 0, therefore 0. And that concludes the demo of the AND gate. Thank you for listening.